Dear children, surface chemistry is the fifth chapter in class 12th NCERT textbook. So, we are going to start with surface chemistry. First, we should try to understand what surface chemistry is. Surface chemistry is the study of processes that occur at the surfaces or interfaces of two bulk phases. Usually, interface is represented by slash or hyphen. Types of bulk phases are solid gas, solid liquid, liquid gas, liquid liquid. In all the four cases, we can very well see that there is hyphen in between. This hyphen symbolizes nothing but interface. Learning will become easy if we know what areas are to be dealt with in the chapter Surface Chemistry. So the main topics are: number 1, adsorption. Adsorption is phenomenon where accumulation of molecular species is at the surface. For example, applying ointment on the wound. Secondly, catalysis. As the name itself suggests, it is the reaction that occurs in the presence of catalyst. One of the best example again from our day-to-day life is breakdown of starch in mouth by salivary amylase, where this amylase acts as enzyme and enzymes are biocatalyst. Thirdly, colloids. Colloid is homogeneous system in which one substance is dispersed as very fine particles in another substance. In our day-to-day life, we come across so many colloids. Milk, butter, blood, they are the example of colloids. Now, we are going to start with adsorption. Before starting with adsorption, we should know what are the learning objectives. Number 1, important terms associated with adsorption. Distinction between adsorption and absorption. Mechanism of adsorption. Types of adsorption. Adsorption isotherm. Adsorption from solution phase. And lastly, the application of adsorption. Adsorption, adsorbate, adsorbing. These are the important terms associated with adsorption that we should try to understand. So here are the important terms. Number 1, adsorption. It is accumulation of molecular species at the surface rather than in bulk of a solid or a liquid. Adsorbate, the molecular species or substance which concentrates or accumulates at the surface is known as adsorbate. Adsorbent, the materials on the surface of which the adsorption takes place is known as adsorbent. Now, one example, silica sachet, it behaves as adsorbent which provides the surface on which water molecule from the moisture gets adsorbed on it. So, water molecule acts as adsorbate and this phenomenon is known as adsorption. Here is the diagram from which things will be clear. The green colored circle in which it is written adsorbent, this is nothing but charcoal on which the gaseous molecules are getting adsorbed. So this complete phenomenon is known as adsorption, and the gaseous molecules that get adsorbed is known as adsorbate, and the charcoal that provides surface for adsorption is known as adsorbent. Few more important terms are sorption, Desorption, occlusion. Desorption is the phenomenon when adsorption as well as absorption occurs. Desorption is removal of adsorbate from the surface of adsorbent. Occlusion is the adsorption of gas on the surface of metal. Now, there must be a question in our mind that why this adsorption takes place. What is the mechanism behind adsorption? What are the various factors that are responsible for adsorption? So, mechanism of adsorption is based on two factors, and they are forces of the adsorbent and secondly the heat of adsorption. Now the first factor that is responsible for adsorption is forces of the adsorbent. We need to observe this diagram carefully. The arrow 1 points towards the particles present inside the adsorbent. Arrow 2 represents the particles that are present on the surface. Arrow 3 represents the adsorption that has taken place. Actually, what happens inside the adsorbent, all the forces acting between the particles are mutually balanced, but on the surface, particles are not surrounded by other atoms or molecules of their kind on all sides, and hence they possess unbalanced or residual attractive forces on the surface, which can hold the adsorbate particle. So, on the surface, because of the residual attractive force, adsorption takes place. Now, the second factor is the heat of adsorption. During adsorption, residual force decreases. As a result, there is decrease in the surface energy, and this decrease appears as heat. It means heat is lost or given out, and the process becomes exothermic and the entropy decreases. Now, let us see here. During adsorption, what is happening? The delta H becomes negative because process is exothermic. Since heat is lost, the randomness decreases, entropy becomes negative. Now we know that delta G is equal to delta H minus T delta S. Delta G has to be negative, then only process will be spontaneous. And this is possible only when delta H is having a value greater than T delta S, as T delta S becomes positive because delta S is negative due to decrease in randomness. Now, if delta H becomes equal to T delta S, then delta G becomes 0 and adsorption does not take place, equilibrium is attained. Distinction between absorption and adsorption. Absorption is assimilation of molecular species throughout the bulk of the solid or liquid medium. Adsorption, accumulation of molecular species at the surface instead of bulk of the liquid or solid. Absorption is a bulk phenomenon. Adsorption is a surface phenomenon. Absorption occurs at a uniform rate. Adsorption increases steadily and reaches equilibrium. The concentration of substance is uniform throughout in the bulk in case of absorption. In case of adsorption, the concentration of adsorbate at the surface of adsorbent is more from that in the bulk. from this figure, things are very clear. First case is of absorption and second one is of adsorption. We can very well see the blue particle represents the substance that is present in the bulk, whereas in the other case it is present on the surface. A very good example is absorption of moisture by calcium chloride, whereas adsorption of moisture by silica gel. Types of adsorption. Depending upon the nature of attractive forces existing between the adsorbate and adsorbent, adsorption can be classified as physisorption, chemisorption. Physisorption, also known as physical adsorption, chemisorption, also known as chemical adsorption. Now, we need to learn about differences between physisorption and chemisorption. This is one of the very important topic on which often question is asked that write 2 points of or 3 points of difference between physisorption and chemisorption. Let's see one by one. Physisorption. It arises because of van der Waals force of attraction. In chemisorption, it is caused by chemical bond formation, as the name itself suggests. Physisorption is not specific in nature, but chemisorption, it is highly specific in nature as chemical bond is to be formed. Physisorption is reversible in nature, whereas chemisorption is irreversible due to formation of bond. Physisorption depends on the nature of gas. More easily liquefiable gas are adsorbed readily. In chemisorption, it also depends upon the nature of gas. Gases which can react with the adsorbent show chemisorption. Now let's see enthalpy of adsorption. It is low in physisorption, whereas high in chemisorption, and the value is 20 to 40 kilojoules per mole in case of physisorption and 80 to 240 kilojoules per mole in case of chemisorption. Physisorption occurs at a low temperature. We can say low temperature is favorable for adsorption. It decreases with increase of temperature because desorption takes place, or the adsorbate molecule they start leaving adsorbent with increase in temperature. In chemisorption, high temperature is favorable for adsorption. It increases with increase in temperature. In physisorption, no appreciable activation energy is needed. But on the other hand, in chemisorption, high activation energy is sometimes needed. Physisorption depends on the surface area. It increases with an increase of surface area. Chemisorption also depends on the surface area. It too increases with increase of the surface area, because more the surface area, more will be the rate of adsorption. Physisorption, it results into multi-molecular layer on adsorbent surface under high pressure. Means many layers are formed. Whereas in chemisorption, it results into unimolecular layer. My dear students, I have highlighted certain words with red. These are the important points which you should remember and can be written while answering the question differentiate between physisorption and chemisorption. Adsorption isotherm. First we need to understand the word isotherm. Iso means same Therm is related to temperature. So, adsorption that occurs at constant temperature. An adsorption isotherm is a graph that represents the variation in the amount of adsorbate adsorbed on the surface of the adsorbent with the change in pressure at a constant temperature. Here, this is the graph showing adsorption isotherm. First, let us try to understand what x upon m is. X is the mass of adsorbate, m is the mass of adsorbent, and x upon m represents ratio of mass of adsorbate and adsorbent. P denotes pressure. Now the arrow 1 points towards the temperature of 195 Kelvin, arrow 2 towards 244 Kelvin, arrow 3 towards 273 Kelvin. If we observe this graph carefully, we see that with increase in temperature, the rate of adsorption goes on decreasing. It means adsorption is always favorable at lower temperature as compared to higher temperature. Freundlich adsorption isotherm. Freundlich adsorption isotherm gives the variation in the quantity of gas adsorbed by a unit mass of solid adsorbent with the change in pressure of the system for a given temperature. The expression for Freundlich isotherm can be represented by the following equation. X upon m is equal to k p to the power of 1 upon n, where x upon m is the ratio of mass of adsorbate to adsorbent, k is constant, and p is the pressure raised to the power of 1 by n, where the value of n is always greater than 1. Now, on taking log of the above equation, that is x upon m equals to k p to the power of 1 by n, we get following expression. Log x upon m equals to log k plus 1 upon log p. Log x upon m equals to log k plus 1 upon n log p. From this graph, we can see that on the y-axis we have taken log x upon m, on the x-axis we have taken log p, and a graph is being plotted. Here the log k represents the intercept, whereas 1 upon n is the slope. Now the two conditions which we should keep in our mind: when 1 upon n, that is the power which is there on the pressure, becomes equal to 0, the x upon m is equal to a constant and the adsorption becomes independent of pressure. Whereas when 1 upon n is equal to 1, x upon m becomes equal to k into p, that is x upon m is directly proportional to the pressure and the adsorption varies directly with the pressure. Adsorption from solution phase. The following observations have been made in the case of adsorption from solution phase. Number 1, the extent of adsorption decreases with an increase in temperature. It's very natural because the adsorbate, they leave the surface of adsorbent. Secondly, the extent of adsorption increases with an increase in surface area of adsorbent. This is also very true. More the surface area of adsorbent, more will be the rate of adsorption. Thirdly, the extent of adsorption depends on the concentration of solute in solution. If concentration is high, that is more solute is present in the solution, adsorption will be more. And if concentration is low, solute present will be lesser in amount in the solution and adsorption will be less. Fourthly, the extent of adsorption depends upon the nature of adsorbent and the adsorbate. बिल्कुल सही, दोनों की दोस्ती होने के लिए एक जैसा नेचर भी होना ज़रूरी है. So nature plays an important role. Freundlich equation related to adsorption for solution phase is as follow. X upon m equals to K C to the power of 1 by n. X upon m, again it is the ratio of mass of adsorbate to that of adsorbent. K is the constant. C represents concentration of solute in solution, whereas 1 by n is the power to which concentration term is raised. We can see that in the previous case, instead of C, when we were talking about gas, it was the P pressure. Now, in case of solution, the concentration term is there. X, mass of solid solute adsorbed. M, mass of adsorbing, that is solution. C, equilibrium concentration. K and N are constant. Applications of adsorption. In our daily life, we find the AC or the symphony coolers. In that, alumina plate is there, which helps in adsorption of moisture and hence controls humidity. Again, in sugar factories, animal charcoal is used to decolorize the sugar solution. When we apply ointment on the wound, adsorption takes place. So there are so many examples. Let's see. Production of high vacuum, gas mask, control of humidity, removal of coloring matter from the solution, heterogeneous catalysis, conversion of vanaspati oil into vanaspati ghee, separation of inert gases in curing diseases, froth flotation process, adsorption indicators, chromatographic analysis. And with this, we have covered all the important points of the topic adsorption. Thank you and have a nice day.